Okay, in this tutorial we're going to finish with the Burger King menu selection problem. We stopped the last tutorial by talking about the slack of our constraints. So we solved this model, we put the integer constraints in there, then we looked at this slack. This slack, again, is a reminder, that's how much more strict this constraint can get before the optimal solution can change. So the vitamin B1 constraint can get more strict by up to 20 units. In other words, I can increase this 40 by up to 20 units before my optimal solution changes. Of course, those constraints with zero slack means I can't make these any more strict without changing the optimal solution. Okay, at the end of the video last time I mentioned that although we do have an integer solution here, it's still not very appetizing, right? 2 burgers, 1 garden salad, 4 light dressings. You may have 0 light dressings. Either of those would be 287. All right, I don't have a drink, for example. So this happens a lot in optimization modeling. So you develop a model, you solve it, and you say, hold on, this is obviously not a good solution. It doesn't have a drink. Well, Solver doesn't know that you need a drink unless you explicitly tell it that you do. So that's what we're going to do now. We're going to do a couple things. First, I'm going to add additional constraints. I only want to see solutions that have at least 1 drink. And I only want to see solutions that have an equal number of salads and dressings, right? Either no salad, no dressing, 1 salad, 1 dressing. You can give me 3 salads, 3 dressings. I just want to make logical sense, the number of salads needs to equal the number of dressings. So let's go to the Improved tab. Okay, so I still have everything in here, all my sum products. You can check and make sure you're comfortable with those. I have a new range down here, other constraints, drinks and salad. What I want to do in row 31 is add up the number of drinks in my order and make sure they are at least 1. Okay, so number of drinks is greater than or equal to 1. If you look at this formula in Y31, it's a sum product of my decision variables, that's row 9, and row 31. I'm going to use this sum product to add up the number of drinks in a particular order up in row 9. So if I order 2 Whoppers, how many drinks is that? That's no drinks, right? So this sum product remains a 0. I want the 2, remember the sum product multiplies this 2 by whatever is in this cell. So I want the 2 multiplied by a 0. That's great. If I have 3 strawberry shakes, I want this drinks counter to say 3. The 3 is multiplied by this cell right here. I want this cell to be a 1. In fact, I want all of the drinks cells to be a 1. These are called indicator variables. Now I have a sum product that every time I add a drink to my solution, it adds 1 to this, because now that 1 is multiplied by this 1. Every time I add something that's not a drink, it doesn't affect my drinks at all, right? My drink counter is still 4, even if I add 55 garden salads. Okay, let's get rid of these, and now let's look at the other one. The next one is more tricky. It's another implementation of the indicator variables that we put here. Okay, this is the sum product of row 32 with my decision variables. I want this to add up salads, and I put a little note here, salads minus dressings. And I want that to equal 0, right? So if I have the same number of salads and dressings, then salads minus dressings equals 0. So every time I have a salad, I want it multiplied by 1. Every time I have a dressing, I want to multiply that by -1. And you should be able to get comfortable with the fact that with these 1s and -1s here, this actually calculates salads minus dressings. So if I have 2 garden salads and 2 light dressings, that's great. Salads minus dressings equals 0. That constraint is satisfied. I can't have 3 garden salads and 2 light dressings. Now this no longer equals 0, so the constraint is not satisfied. So let's solve it again with these kind of preference constraints added. So it's not just that I'm trying to get the cheapest order that satisfies my dietary constraints. I also want a drink, and I also want a logical combination of salads and dressings. So let's go to Solver, and we'll put the entire model back in again. My objective is to minimize the cost. My changing cells are all of the possible things that I might order. This is what I want Solver to fill in. I want Solver to find the best things to put in those red cells. What are my constraints? Well, I still have my bad stuff. Solver's going to add up the bad stuff and constrain it to be less than these maximums that I've specified. I've also put into my spreadsheet some minimums for good stuff, and I want to make sure that whatever order Solver returns to me satisfies all of these minimums for good stuffs. Now, since I want to continue to add constraints, I'll click Add again. I also have this constraint for drinks. This is the cell where I count up the number of drinks. I want that to be greater than or equal to 1, at least 1 drink. Here's my cell where I look at salads minus dressings, and now I'm going to use this equality constraint here that we haven't used yet. I want that to equal this cell right here, 0. Remember what else I need to do? I need to make sure that it only tries integer solutions. So I'll constrain all of my changing cells to be int. Okay? I only want to look at non-negative values again. Since I have integer solutions, I always go to options and make sure my integer optimality or my tolerance is 0. Now I can solve this one. Solver found a solution. All constraints and optimality conditions are satisfied. For 332, here's a solution that makes sense. A hamburger, a garden salad with a light dressing, and a chocolate shake. That's $3.32. You can check every single constraint. It doesn't have too much of any of the bad stuff. It has at least enough of all of the good stuff. It gives me a drink, equal number of salads and dressings. I've added more constraints, so it is a little bit more expensive than my initial one where I didn't have to worry about drinks and dressings and things like that. But now I have a solution that makes a little more sense. Okay, so that's a pretty extensive example. We went through a lot of things there. Please go through it slowly yourself. If you have any questions, you're likely to have some questions, please don't hesitate to ask me or your tutor to be sure that you can go through this complex problem, formulate these optimization models, understand the integer constraints, the slack, everything else that we did. If you can understand this problem, then you have a very solid grasp on optimization modeling.